Hello, and welcome to the Building Secure IoT Solutions with Azure Sphere and Azure IoT Hub. My name is Dave Glover. I'm a cloud developer advocate based in Sydney, Australia, and I've got a focus on the Internet of Things. Now, it's also my great pleasure to introduce Mustafa, who's a student ambassador based in India. So, Mustafa, perhaps you could tell us a bit about yourself, please.
Hello everyone and good morning. I am Mustafa Saifi from Maharashtra, India, and I have been a Microsoft Student Ambassador for the past 6 years. And I am very interested in IoT, and that's why I'm over here. And I am in my fourth year of final year of my engineering, doing my majors in information technology. You can follow me at I am Mustu on Twitter. Thank you.
Hey, that's great. Oh, and as you might add, you can also follow me on Twitter at dglover. Now, security, without a doubt, is the biggest challenge facing the IoT industry, and it is often overlooked in a rush to kind of bring products out to market. And really, security should be at the heart of every IoT discussion, every project that you're actually kind of working on, or every product that you're working on. Now, Azure Sphere is our platform for building highly secure, connected IoT devices. Okay, so now in conjunction with Oxford University, we've developed a module which is focused on Azure Sphere and IoT Hub, and really this module or this session is really going to be in support of that IoT module. So you can kind of watch along on the module as well, but my recommendation for now is that you just kind of follow along the session, and then this will kind of give you a lot more background as to how to go and build solutions and what you're going to be doing. Now, there's also plenty of opportunities to ask questions. So please ask questions on Twitter. Now, the hashtag is #LearnTV, and there are a bunch of moderators who will be monitoring those hashtags and helping answering questions. And Mustafa and I are also going to do our best to keep an eye on the questions coming through, and we'll try and answer questions as we kind of go. Now, the agenda for this session here, we're going to look at IoT security risks in general, just so you kind of give you a bit of an idea of the types of attacks that are possible. We're going to talk about Azure Sphere security. We're going to look at some services in Azure called IoT Hub and the device provisioning service. And then we've got a couple of demos behind this. We're going to show you how you can how you can securely stream data from an IoT device, an Azure Sphere device to IoT Hub, and also how you can remotely control that Azure Sphere device from IoT Hub. Now, there's also going to be an audience participation opportunity. So you'll be able to actually control that device that's sitting on my desktop from a web page from the comfort of your home. So Mustafa, can you talk to us a bit about what the overall scenario is going to be for this MS module, for this learning module?
Sure. So let's assume that you are a scientist in a microbiology lab who is responsible for storing samples from a test. Now you want to build a system that monitors the environment around the lab equipments in real time. Now the system should have the following room conditions. It should measure the pressure, the light, the temperature and humidity. Now previously these were recorded manually by the lab assistants using sensors at regular intervals. So the manual recording of the ambient condition was a very tedious job, and it is also prone to human errors. Now having any issues with the sensors can invalidate the test results that you obtain from your experiments. Maintaining the room conditions is accurate and is very critical for maintaining the lab. The lab needs to maintain the right conditions to help you get more accurate results. Any variation in the conditions can affect the equipment temperatures during the storage, manipulation of the samples, specimens and lab equipments. Now this could impact the ability to produce the correct results, which can directly affect the economic impact of the organization. Now Dave will give some headlines on IoT that are going on right now.
Yeah, cool. Thanks, Mustafa. Hey, look, I just also want to point out that though this learning module is very focused on a lab, it's really completely applicable across a whole range of environments. So you can imagine you might want to monitor the temperature and pressure and humidity in a factory, for example, to make sure that the working conditions are suitable for people working in them. Look, it could be monitoring, it could be a smart home that you're trying to build, just trying to automate perhaps the air conditioning system in your home or an office block, or it could be a smart city. So really what we're going to talk about here, though it's focused around this lab scenario, really is pretty applicable to a whole range of different scenarios. So really not a day goes by without some sort of headline related to IoT security. Now, look, it could be baby monitors that have been hacked. It could be children's toys that are being hacked. We've got cases of vacuum cleaners which have cameras in them, which are being used to spy on families. There's even been cases of heart pacemakers in cars being hijacked. So these are real in terms of the types of attacks that are happening with IoT devices. And the key thing about it is that these devices are being used in ways that they were never designed to be used. And really, they just weren't built with security in mind. It was opportunity for someone to go and start kind of reprovisioning that device or using it a different way. Now, obviously, these attacks can have really kind of significant impacts on social environments, can have a significant impact on economies, be it the economy of a business or potentially even a country if a city is locked down. And these obviously have huge reputation implications. And really, none of us want to be in the situation where we need to be recalling devices because of security issues. Now, kind of almost an infamous known attack is the casino fish tank attack. Now, Mustafa, can you tell us a bit about this casino fish tank attack?
So yes, this is a very great example how IoT goes wrong when it was not intended to. So there was this casino. It had this unique fish tank aquarium. It had sensors and other cameras in it. So what these hackers did was they got into the security system using the sensors in the fish tank. Now by the time the officials realized that something is wrong, these hackers they got access to the database and they uploaded and downloaded 10 GBs of data, although it was secured later, but once the deed was done, the data was lost. Now this was a great example how IoT device was not used in the way it was intended to. Now Dave, can you tell us more about how Azure Sphere addresses this security concern?
Yeah. Hey, thanks, Mustafa. Hey, look, I just want to also add to this. There were a whole level of kind of multiple layers of things that were done incorrectly. So this device was connected up to the corporate network, for example, with very little security on it. And there was just kind of asking for problems, particularly in an environment where the data was super critical. Okay, so the next thing I want to talk about is approaches to mitigating security risks. Now, as I'm sure you appreciate, security is very much a journey, and getting security right is complex, it's expensive, and it's highly specialized. And the main thing about it, it's ongoing. So security vector attacks or security attacks are constantly changing and getting more and more cunning as time goes on. Now, Microsoft has a long history in building internet connected systems. And it's these lessons that we've learned, some of them hard lessons along the way, that we're bringing to Azure Sphere. Now, Microsoft and the industry have pulled together what we call the 7 properties that required for highly secure devices. Now, it's not my intention to go through these all in a lot of detail, but if you go and check out the link below, aka.ms/7 properties, you'll get a much more detail question. You get much more detail on each of these 7 properties. But kind of touching on a couple of these, we've got what we call the hardware root of trust. And this is typically where you have hardware protecting normally a set of cryptographic keys that really identify that device, and they have to be unforgeable. We have concepts of defense and depth. And this is multiple layers. And normally these layers would be typically protected by hardware. And the idea behind that, if someone was to attack into a system, they got past one layer, then there'll be another layer of defense that prevents the attack from rolling up further. We've got things like certificate-based authentication. Now, a lot of IoT attacks, believe it or not, happen because of the use of very common passwords. So there was a very well-known attack where they took over security web cameras, and these cameras all used the same passwords. And of course, once you go onto those, then you're able to take control of those devices, and they're actually used as a denial of service attack. So that's where it's super important not to be using passwords for IoT devices and applications. You use certificate-based authentication. Now, the other one I like is error reporting. If you don't know that something's being attacked or that there's a problem, then of course you can't mitigate against it. So it's super important to be able to have a way in which you can actually understand the kind of the systems and the devices you got deployed into the field and understanding how those are behaving. Now, as I mentioned a moment ago, that's really is the depth I'm going to go into. Do check out the aka.ms/7 properties, and you really find a lot more information about these properties. And it really is an easy to consume document that you'll learn a whole lot more about. Now, Azure Sphere is made up of three components that implement these 7 properties that required for highly secure devices. Now, the first part of the Azure Sphere is this thing called the Azure Sphere Certified Microcontroller, and it is available from a number of partners who are building Azure Sphere plus a silicon. And the most key part of this is that they have a burnt-in hardware root of trust, which is a set of cryptographic keys that are protected by hardware and, most importantly, are not forgeable. The next part of Azure Sphere is something we call the Azure Sphere operating system, and we will maintain ongoing updates to this operating system as new threats emerge against the platform. We can patch those and then roll those updates out into the devices. Now, interesting enough, the Azure Sphere OS is actually built from a hardened version of a Linux kernel. So that's kind of the heritage of this. Now, the third component is this thing called the Azure Sphere Security Service, and its role is really to guard every Azure Sphere device. It's responsible for things like brokering trust, detecting emerging threats that might be happening across the board. It's responsible for things like renewing device security. Certificates are updated on a daily basis, and also a way for aggregating reports, aggregating potential attacks on devices so that we can understand what is going on in potential security attacks. Now, what I want to do is delve into a bit more about the overall architecture of an Azure Sphere. And this is common across all the Azure Spheres, no matter who has manufactured them. So the main thing about an Azure Sphere, it's known as a multi-core microcontroller. And it is made up of 3 cores that you can deploy applications onto. So there are 2 core Cortex M4 cores, and on those cores, you can run real-time code. So it could be bare metal code, for example, or maybe you're running an RTOS, so a real-time operating system. So it could be something like Azure ThreadX, or it could be FreeRTOS, or maybe you're going and deploying a tiny machine learning model onto the device, and you want to be able to do local inference of machine learning on the actual Azure Sphere as well. On the right-hand side, we have the Cortex A7. Now, this is the kind of type of core that you'd probably find on a mobile phone or maybe on a Raspberry Pi, and it's quite a capable core. It's also known as a crossover MCU because it's capable of running kind of a high-level operating system as well as these kind of real-time capable applications as well. And that Cortex A7 is responsible for running this hardened version of embedded Linux, as well as running a high-level application. And the other core that you don't have access to is called the Microsoft Pluton Security Subsystem. And it is responsible for really ensuring security policies are actually being enforced. Now, you'll also notice that there is a firewall around each of these cores. Now, this firewall does a number of things. So the first of all, there is what we call a silicon firewall. And this firewall and the policies behind that ensure that applications can only access things like peripherals, like GPIO or pulse width modulation peripherals, or things like that, that have been actually declared. So by default, the Azure Sphere is secure by default, and you have absolute access to no resources. It is locked down, and you need to explicitly go and define, hey, look, I want access to GPIO ports, for example, and which ones you want. So the silicon firewall is responsible for really guarding the overall kind of device infrastructure and access to various bits of hardware. Now, the other thing that the firewall does, it is responsible for protecting against network endpoints. And again, it's very much, you explicitly define the network endpoints that the applications running on this device can actually access. So, for example, in the opportunity that maybe this device did get taken over, then the device would still only be able to access the peripherals that have been defined on the policies and the network endpoints that have been defined in policies. So very much locked down by default, and it can only access resources that you have explicitly defined. Now, Mustafa is just going to talk about the types of boards that are available in the ecosystem that you can start developing on. So Mustafa, perhaps you can just talk about these boards.
So yeah, there are multiple types of boards available in the market to use with your Azure. So one of the most famous and mostly used board is the EventID board, the board developed by EventID. So this board has a lot of sensors built in and a lot of options to add more sensors to it. One of the options is the click option. So as you can see on the board, there is something called click number 1 and click number 2. So there are these small modules available called clicks. You can get it off the shelf from the market, and all you have to do is grab one clipboard and attach it to your board. Now what happens is when you attach this click circuit to the board, the sensors get activated and you can use those sensors with your clipboard. There are other pins called Grove connections. So what these Grove connections are is there are these groove sensors available in the market. It has wires and you can just attach these groove sensors to the wires. There are other options as well. There are LEDs and other indications on the board. Now there is this another board developed by Seed. It is called MT3620 development board. This board doesn't have sensors onboarded. So it has GPIO pins. What you can do is you can grab other sensors and attach it to these boards. You can also add grooves connections to this, and it is a second option to the EventID board. Now there is a miniature version of the previous board, the MT3620 mini board. So this is a more miniaturized version of the previous board. It also has GPIO pins. It does have less number of pins, but it can do the job that you want to do. That's it. So yeah, Dev.
Yeah. Hey, that's cool. Thanks, Mustafa. I might just add in a couple of extra things here. So as Mustafa pointed out, there are lots of different types of boards that you can click into these. So you've got the click boards and you've got Grove boards, and you can find those in various typically online websites for these boards. Now, of course, the important thing as well is you also need to have a device driver for these boards. And again, you'll often find them. So GitHub's a great place to go and check it out. But you'll often find the manufacturer will write their device drivers in C, and it makes it very easy for you to then go and implement those device drivers and those sensors onto these boards. But the whole idea behind these boards is to make it really easy for you to go and prototype out a solution without having to kind of get the soldering iron out and be an electronics engineer to go and build these devices and build these prototypes. And then really when you've got a great idea and perhaps you want to go and take it out to market, then you wouldn't go and build a solution on one of these developer boards. You would then go to the microcontroller, the Azure Sphere microcontroller manufacturers. So you go to Avnet or AI Link, for example, and you say, hey, look, I want 500 of these boards. I'm going to do an early production run. So that's the kind of idea how you'd go and use these boards. So I just want to talk about the components that you need for this learning module. So the first thing you obviously need is Azure Sphere. And I said, recommend you go and use one of those prototyping boards, the Avnet boards or the boards from Seed Studio. You also need to have installed the Azure Sphere software developer kit. And we support development on Linux and on Windows. And you can use Azure, so you can use Visual Studio Code and you can use Visual Studio 2019. You also need to set up an Azure Sphere tenant, and you need to be able to log into that and authenticate. And you need to do what's called claiming a device. And it's a one-off operation. And the really important thing to keep in mind is that you can only claim a device once. So it's really important to think about what tenants you're going to be claiming them into. Now, you can also define multiple users in that tenant, and you can kind of give users different roles. So for example, someone could be an administrator, someone could be a contributor. So you have the ability to be able to manage those devices and have multiple people manage them. But the idea is you claim a device and then you can remotely manage those devices. Now, in the demos that we're going to show you, what I've done is I've taken it and I've enabled the developer experience on these boards. But normally you would deploy applications from the cloud. But in the case I'm going to be showing you, I'm going to be deploying them from Visual Studio on my desktop. You also need to have an updated version of the Azure Sphere OS operating system. Now, the OS ships on the boards, but you normally need to just make sure that the operating system is up to date. And you'll see in the learning module, there's instructions on how to make sure that you're running the latest version of the operating system. And of course, you need to be connected to the Azure security service. As I mentioned before, it's a thing responsible for brokering trust and monitoring the application and detecting errors and reports and things like that. Now, before we delve into this demo a little bit further, what I want to do is just talk a bit about what we call an IoT reference architecture. And this is as much as anything to kind of give you a bit of a sense of where things and how things kind of fit together. So an IoT solution is made up of things, so devices in this case, and the device is an Azure Sphere. And that Azure Sphere device, in this case, is going to be the AVNet board. And that AVNet board is going to be streaming data to our cloud gateway. Now, the way this really works is in the world of Azure, a cloud gateway is known as the Azure IoT Hub. Now, there is also what we call a helper service, which is called the device provisioning service. And it is responsible for what we call zero-touch device provisioning. And it makes it very easy to go and deploy out thousands or hundreds or thousands of devices. And it becomes super critical because it really helps to reduce the complexity of rolling out devices out to the field. And what that enables you to do is get away from the whole idea of having to hard code in the connection string to a cloud gateway. So basically, that connection string is negotiated at startup time using the device provisioning service. Now, this learning module really just takes the Internet of Things reference architecture really as far as connecting this device and starting to stream and control data into a cloud gateway. Now, normally, of course, you want to kind of do something with that data, and you'd normally want to go and transform that data, or you want to go and do what we call stream processing across that data. And normally you would split out data into warm path, so data that you wanted to be more readily available, and cold path data stores. And for example, you might go and use that cold path data where you've kept a record of all the data that's flowing in from those devices, and maybe you want to go and train a machine learning model, for example, and maybe create a tiny machine learning model, which you might then want to go and deploy back out onto the Azure Sphere. So really kind of interesting options. And of course, you might want to integrate it with some sort of backend process. Maybe as that data coming through, you might want to automate the temperature in the lab environment or in a factory or in your home. Okay, so what we're going to do now is just kind of go through a bit of a demo. So Mustafa is going to show us how you'd go about, what process you go about provisioning a device, provisioning IoT Hub and the device provisioning service.
Yes. So let's talk about the device provisioning. So one of the first primary requirements you need is you have to go over to this learning path called Develop Secure IoT Solutions for Azure. This was created in collaboration with Oxford and Microsoft. So doing this learning path will get you benefits. So when you scroll over there, you'll see an exercise called Exercise Connect a Room Environment Monitor to Azure IoT Hub. So one of the prerequisites is you need an Azure IoT account. You can make one at aka.ms/Azure for students. And then when you are done with the account, all you have to do is log in and then click on deploy to Azure. So once you click on deploy to Azure, this will take you to the portal if you are already logged in, and it will create a custom template for you. So when the custom templates open up, you just have to deploy it. One of the requirements is you need a subscription. So I have a subscription selected over here. Now resource group. So I'll talk a little about resource groups. So what resource groups are is, let's say you have multiple applications on your cloud, and resource groups are those modules that keep all these resources that you're using collected at one place. So what you want is all these resources in one resource group so that you don't get confused. So if you are having a team that is working on IoT, all the resources used by those members in the IoT team will be in a resource group. So let's create a new resource group instead of using an existing one. So we can say this as IoT RG resource group, and let's click OK. So now a new resource group will be allotted and all the resources that we use will get allotted to this. Now you can select the region nearest to you. So let's say I select Southeast Asia. And then one of the important things that you need to know about is the IoT hub tiers. So can you Dave show us what this F1 and S1 is over here?
Yeah, sure. Thanks, Mustafa. Hey, so when you set up an IoT hub, you can select multiple different tiers depending on what you need, mostly depending on how many messages you plan to send a day. Now, there is a free tier, which is the F1 tier, and that gives you 8,000 messages per day for free. So it provides a great way in which you can get up and running with IoT Hub with kind of zero cost. And that enables you what we call bidirectional communications. So you can both send telemetry and messages from a device, as well as send messages down to the device to maybe go and control that device. Now, you can also go and select other tiers. So I've just defined two tiers as an F1 and an S1 tier. There are actually tiers greater than that. The S1 tier, from memory, gives you around about 400,000 messages per day, which should be more than enough for most solutions. So, hey, thanks for that, Mustafa. I think that's probably so. And then what you would do is you could then go and click on create, and that would normally take around about 5 to 10 minutes to process. So what we've actually done is we've created another Azure IoT Hub just that we're going to be using for this demo. So that kind of gives you a bit of a sense of what the process to go through this. So there's a template, and it makes it super easy to go and develop applications. Okay, so the next thing I want to do is just go through a quick demo as to how you can actually go and connect an Azure Sphere device to IoT Hub. So what I've got loaded here is I've got Azure Sphere, Visual Studio Code, and I've got a starter template. Now this template is also available, this example is also available in the GitHub repo that you should actually be downloading as part of the process. And the first thing I'm going to do is go across to what we call the app manifest. And sorry, click on that. Yeah. So as I mentioned during the talk, is that an Azure Sphere device is locked down by default. So it has no access to any resources. So you need to be explicit about defining all resources. And this could be hardware resources as well as network endpoints. So, for example, in here, I'm enabling this application to connect to a pin called LED1. Now, further inside the application, there is a mapping of LED1 to the physical pin. And there is also another pin that I'm going to be using called relay. And again, inside the application, there is a mapping for that down to the actual pin on the device. I also need to be using ITC because this board has sensors on which are available on an ITC bus. And also just this happens to be using some power controls. So I could, for example, I might want to remote control a force reboot of this device for some reason. As I mentioned, so those are kind of more the silicon and the OS capabilities that you can define, but you also need to be extremely explicit or absolutely explicit about what network endpoints you need to connect to. So in this case here, I need to be connecting to what we call the global device provisioning service endpoint. And we're also going to be sending data to an IoT hub. So this is the URI for the IoT hub that we've already provisioned, as well as a device provisioning service that Mustafa provisioned. So if you didn't explicitly define these endpoints, then you would not be able to connect to them, and you'd be sitting there scratching your head thinking, why is this application not working? Because I'm sure I've done everything right, and it doesn't seem to be sending data to the internet. Now, this is true for all connection endpoints that you might have inside your application. So for example, in this case here, we're connecting to the cloud, but you might have a local on-premise or local service. Maybe you want to connect to a database that's running on a Raspberry Pi that's sitting next to you, and you want to be able to connect to that. You would need to explicitly set the endpoint of a service that you're running on a local device or some other device on the internet. Okay, so those are the capabilities, and that's defined there as this app manifest. And the learning module will go through this and explain it in, again, a lot more detail. Now, no C application would be, of course, a C application without a main.c. And I just want to talk through this application. So it's pretty much a standard C application, and I just want to talk about this in a bit more detail. So the learning module is actually built, has a number of helper libraries that are built from the Azure Sphere Software Developer Kit samples. And you can find these samples up on github.com/Azure Sphere samples. So when you look at this application, it's super important to appreciate that there is a set of helper libraries, and these helper libraries are called the Azure Sphere Learning Path libraries. And there are a set of libraries that I've written, and they just help facilitate the application development. Mostly it's about just simplifying highly repetitive processes. The board supports the 3 developer boards that are available in the marketplace. And you also need to go and specify which board you're going to be using. So there is a CMake file, and over here, what you would do is you come up here and you just comment out the board that you're using. In this case here, I'm using the AVNet board. And if we just go through this, then the anatomy of this application is pretty much what you'd find for a typical C application. So we've got a whole lot of header files up here. The first bunch here are for the learning path libraries. As I mentioned, these are a set of libraries which just kind of facilitate really common stuff that you need to do, and it just makes your life a lot easier as a developer. And those libraries are all open source. You can use them and or extend them and even contribute back to them would be even nicer. There are a stack of system libraries that ship as part of Azure Sphere. And you've got things as you'd expect. So for example, GPIO libraries for accessing GPIO, for power management. You can see I've got some libraries in there for time management and stuff like that. And then we've got libraries on here for the board. And the board I'm using is the AVNet starter kit, and it has a set of C libraries to go and access the sensors. So that's pretty much the main part you expect of most C applications. And then the rest of it here, there's a buffer that's been defined. This is the buffer I'm going to be using for sending data up into the cloud. And we've got a template here which defines the format of the JSON document that we'll be sending up to IoT Hub. Plus, I also have some message properties. And these message properties are really useful. They've kind of metadata. Think about it, metadata or data about the data that you're going to be sending up to the cloud. And having these properties makes it much easier when you're doing processing up on the cloud. So for example, here the app ID is lab monitor, and maybe you need to go and partition out the data as it's coming up into the cloud. Knowing the format of the data, are you using JSON, are you using Avro, different types of, or Google Protobuf, different types of message formats. Again, if you have that metadata, then it makes it much easier to go and build backend applications. Things like the schema version are super useful. And I'll just go through this a little bit more detail. We also have a couple of helper functions in the C application. The first one here is just to go and initialize peripherals and handlers, and it goes and opens up what I call sets. So it gives you an easy way to open up a bunch of, in this case, GPIO. So you might define multiple GPIO pins that you want to open, and you just go and basically define them in a set. And then this function here will go off and open all the peripherals that are defined. The same thing, what we call device twins, which I'll get more detail in a moment. Starting up timers, I'll talk about in more detail shortly. And there is another function here called close, which just basically does the opposite of open. And then, of course, we've got the main entry point into the application. And of course, the first thing it does is calls the initialize peripherals and handlers. And when the application exits, it calls off closing peripherals. Okay, so hopefully that gives you a bit of an idea of the kind of the structure of the application. And this is the same structure you'll be using for your learning modules. Now, I'm just going to copy and paste a bit of code across into here. So the first thing I'm going to do is paste in a timer. Now, the recommended programming model for this, for an Azure Sphere, is to go and use a timer. And what this is doing is I'm setting up a timer which is going to fire every 5 seconds and 0 nanoseconds. And when this timer fires, it's going to call a C function called read sensor handler. And I need to go and initialize this timer. So down here, We'll just update this, and you can see I've got a reference to this read time sensor structure that I just set up. And of course, I need to go and implement the read sense handler. So if I come over here, we'll copy this code in, and this is just the handler that's going to be called by that timer when it fires every 5 seconds. So what I'm going to do now is deploy the application across onto the Azure sphere. So of course, it's going to compile it, and it's going to copy it across to the Azure sphere. And then the next thing it's going to do is attach the debugger to it. And you'll see in a moment that the remote debugger is being attached. I'll just make the screen a little bit bigger. And what we're going to do in a moment, we're going to switch across to Mustafa's machine, and we will be able to see the telemetry coming through onto the device. Okay, so the first thing it's done is it's found the sensor on here, it's setting up the security, and now it's going to start streaming data. So we jump across to Mustafa's machine, and we'll be able to see this telemetry now finding its way up to IoT Hub. So Mustafa, do you want to share out your machine? I think you might be on mute. Yeah, cool.
Yeah. So what we can do is, first of all, we need this app called Azure IoT Explorer. Now you need to download this app, and I have this key from Dave. So you need this key to add a connection. So all you have to do is copy paste the key from the go to IoT Hubs, add connection, and you have to paste that string over here, and you have to save it. So once you save it, all the data will be loaded. Click on this, and you have all the data over here. Now, when you want to see the telemetry data on the left hand side of your screen, you can see telemetry over here. So this is the telemetry screen, and you have to click on start. So once you click on start, it will start accessing the board and start receiving the events. All the things that Dave mentioned in his code, the JSON file, all the data will be visible on my screen. Dave, can you explain about this?
Yeah, so you'll see that. So first of all, you can download the Azure IoT Explorer from GitHub, and it's a really useful application just for kind of as you're building an application to kind of see what and control and view the behavior of the data that's coming up from the device. So the first part of the data that's coming up through is the body of that message, and you'll see that there goes we've got the temperature, humidity, pressure, and light message ID. I use message ID to just kind of get a bit of a sense of how many messages that have been sent up. The second part of that message is the application properties. And you remember I mentioned in the C application, there is a set of metadata, basically data about the data. So this metadata here, as it's flowing up into the system, in the backend systems, you can start using that data to be able to make more intelligent decisions about that data that's flowing through. Now, in the actual learning module, I actually use the command line to go and view that data. But the IoT Explorer is a nice, friendly, easy way to go and do that. And you can run this application on Windows and Linux and Mac OS as well. So, hey, thanks so much for that, Mustafa. We'll just jump back to my screen. Okay, so we're back on my machine, and you can see it's still sending telemetry up to IoT Hub. So we'll go back to the slides, and we will see, okay, so we've done the demo here. So the next part I want to talk about is ways in which you can remotely control, in this case, we're going to remotely control a lab light from Azure IoT Hub, and we're going to use something called direct methods. And I'm just going to talk through what a direct method is. These are kind of the standard ways in which you would go and be able to control a device. So in this case here, we've got an IoT Hub application. Now, the IoT Hub application that we're going to be using is actually going to be using the IoT Explorer that Mustafa just showed you. But normally you go and write an application. That would be the application. That application would talk to IoT Hub. So what you would do from that application is that you would invoke a direct method. And in this case, the direct method we're going to invoke is called light control. And then what it will do is that IoT Hub will see that you've invoked that. There's a set of APIs to go and do that. IoT Hub will say, okay, your application has invoked this direct method called light control. It will then bundle that up into a message and then do what's called a method request. In this case, we're sending it across to the Azure sphere. Now the Azure sphere, and that we'll need to have code there, which will be looking out for direct method requests, and it will map that request to a C function handler. That handler will then apply an action. And in this case, the action is going to be to turn the light on. And then the direct method will respond back to IoT Hub. And it's very much like making an HTTP request. For example, you would get an HTTP status code of 200 if it was successful, 400 if it failed, or 500 if it failed. It's that kind of concept. Okay, so what we're going to do now is we're going to just show you how you can use direct methods inside the application. So as I mentioned, what we're going to do is we're going to control a light switch. So the first thing I need to go and define is GPIO that's going to be controlling this relay. So I've got another data structure here. It's called learning path peripheral GPIO, and the variable I'm going to define is called relay. And it maps to a pin called relay on the board. I'm going to set output direct. I'm going to be setting it for output, and I want it turned off to start with. I then go and define the direct method. Oops, sorry, I just need to go and initialize that peripheral, that GPIO. So we just initialize that. And then I also need to go and define the direct method. So in this case here, what I've defined is a direct method, and it's going to be looking out for a method called light control, and it's going to call the C function as it hits the device. I need to initialize that direct method function. So again, I just add it to the collection of direct method bindings, and I obviously need to have some implementation. And we'll just close that, and we'll go and put the code down here. And what I'll do is I'll set a breakpoint in this code, and we'll just stop the existing code running on here, and I'll now deploy that code onto the Azure sphere. So what's going to happen is in a moment, Mustafa is going to show us how he's going to start that breakpoint up, and you'll see the code being hit in the application. So the code's been deployed onto the Azure sphere, the debugger's being attached, and what we're going to do now is switch across to Mustafa's machine, and Mustafa, you're going to kick off this direct method.
So yes, so we'll come back to the Azure IoT Explorer, and you have to go to direct methods. Now you have to mention the method name and the payload. So I already have that data with me, and as Dave has done this in his code, we'll just take the method name as light control and the payload as this. It's a JSON format. So this is the thing, and let's set the connection timeout in seconds up to 50% and the response timeout in seconds up to 50%, and then we'll invoke method. So this will start invoking the method. Yeah.
Okay, that's great. So when that invoked the direct function on this device, and I can see as I step through this code, I can look at the state. In this case here, the state was true, and if I go and click on that, what that would do now is that this has just turned on the light, and you can see if I go and run this one. So I think Mustafa's fired off another one. You can go and do that. Now, this is if you've got a moment, and you've got to be very quick about this because we are running a little bit tight on time, is if we go to the slide here, if you want to go and connect to that link, aka.ms/learn/IoThub/demo, if you put that into your browser, so aka.ms/learn/IoThub/demo, and Mustafa, perhaps you can give that a go as well, as I will. There is a web page here. In fact, I'll bring up the web page onto my screen. So if you have got to this page, this is a page which I've written as a website you can try, and you can go and turn the device off. Now, this is a great example of making sure this is actually turning off. This is it's probably hit the breakpoint on my application. Hang on a second. So if anyone's tried that and wonder why it's not worked, we'll just turn off the breakpoint. So if you are there and giving this a go, and there's somebody out there who's firing this up, so you can see that this is a great way. So this is an example of an IoT Hub application. And what this is doing behind the scenes, it's actually calling an Azure function that is then sending a direct message method to IoT Hub, and then that message is being forwarded onto the device, and that's being controlled. So you can see how that's working. So someone's turned it off, someone's turning it on, and maybe hopefully I can get you to stop sending messages there for the moment. Okay, so thanks for that. So the next thing we're going to do is look at the next part of the demo. And so where are we up to? We're up to, yeah. Okay, so that part of the demo there was showing you how you can go and control devices with direct methods. And if I could encourage you to stop clicking on that button, that'd be super awesome. Okay, so the next part of this demo is we're going to show you how you can control the lab environment with what are called device twins. And in this case, what we're going to do is we're going to change the rate in which we sense data on the Azure sphere. So we're going to use these things called device twins. Now, again, you would go and build an application to go and control this, but we're going to use the IoT Explorer. And in this case, what you'd have is you'd have an application which is talking to IoT Hub. There's an API that you can call. And what you can do is you can go and set what we call the sense rates. In this case, the example is going to set what we call the desired state of, in this case here, the sensor measurement rate. And then what will happen is that IoT Hub will send a message, will persist that state into something called the IoT Hub device twin. Now, every device that's defined in IoT Hub has a device twin. And that is a JSON document which basically describes the state of the device. And it's a cloud state of the device. So you can go and set the state. And then what happens is that IoT Hub will then send a device twin message to the device. There will be the device, you have to go and define a handler for that message. In this case, we're going to control the sensor measurement rate. Then, of course, you'd need to go and implement that change. In this case, we've got a function there which is going to change the rate in which we measure it. We're going to change the time. And then you will do what's called report back the configuration. So you have what's called a reported state. And the idea behind that is that then your application that you've built, a cloud-centric application normally, you could then go and query these device twins and find out what the state is of this device. So it provides a way which you now have a cloud kind of mirror of the state of the device that you can now query in the cloud. So for example, you might have thousands of devices out there and you want to find out all devices where the light is turned on in the factory, for example, or in the lab. That would not be feasible really to go out and ask each device, hey, look, what's your current state? Are you turned on or are you turned off? Is the light turned on or turned off? So you would use device twins for that. The state on that device is reflected back up into the cloud. And now you just need to do a cloud query of that data. And obviously makes applications much more feasible to go and query devices en masse. So as I mentioned, every device has a JSON document, and we'll show you how that looks in a moment. So we're just going to jump back to the demo, and we're now back in the code. And thanks for stop clicking on that link. And we'll just come back up here, and we're going to add in a bit of extra code. And we'll just come across here. Now, what I'm going to do is I'm going to add in the code for the device twin. So the first thing I need to go and do is add in the code for the device twin here. So this is another structure which is part of the helper library that I mentioned before. So it's part of this Azure Sphere Learning Path library. And again, it's just basically wrapping up the code that you'll find in the Azure Sphere SDK samples. So the first thing I'm defining is this thing called a sample rate, and it's a device twin, and you can see it's of type device twin binding. And it's going to be looking out for a device twin property name called sample rate seconds. And look, you can define the schema. In this case, I'm expecting an integer. And this is the C function that I'm going to call when the device receives a device twin. And what we'll do now is I'm just going to initialize this device twin with that definition, that binding that I created up here. And the next thing I'm going to do is I'm going to implement this handler called sample rate device handler. And I'm just going to copy across the code. into my code section. And this is the handler that I'm going to be called. So you can see that maps to the handler up in that structure that I defined. And what we'll see up here is I'm going to set a breakpoint in this device twin handler, and we'll be able to see this breaking. Now we'll deploy this code onto Azure Sphere. Now, while it's deploying, you'll see I've kind of got some common sense stuff. This is just stuff that you should do when you're building any IoT solution with data's coming in. You should do some basic validation. So the first thing I'm going to do is just validate that the sample rate is kind of reasonable. And for this solution, I defined that the time needed to be greater than 0 seconds and less than 5 times 60 seconds, so less than 5 minutes. And then you can see what I'm going to do is I'm going to change the timer. And then I'm going to do reported state. So I'm going to report back into the cloud what the current state is. Now, what's happened here is because the cloud already has some state on this device, set up for this device, you can see if I step through this, and if I hover over the time, you'll see that the current state for this is 5 seconds. So what I'm going to do is change the timer, and then I'm going to report back that state. So what we're going to do now is switch across to Mustafa's machine, and we're going to show you how Mustafa can control the sensor rate for this.
Yes. So we'll come back to the Azure IoT Explorer, and we can go to device twins that Dave was talking about. And as you can see over here, so this is the data that I got from Dave's setting. And as Dave was saying, the value was 5. Now I can turn this value into, let's say, 2. Is it okay? 2 is okay, Dave?
2 is perfect. Yep.
Okay, fine. Then I'll set it to 2. I'll set the value, sample rate seconds in value, to 2. And I'll save it. And that's it.
Okay. So if I hop back across to my screen, you'll see that when Mustafa updated that JSON document, and keep in mind, you would not normally be using the IoT Explorer to go into this. You would obviously go and build an application which was user-friendly, be it a web page or an application running on a mobile phone or desktop application. So Mustafa updated that, and I think you changed the value to 2. So if I hover over that, you'll now see that there goes the value of 2 inside the debugger. And we're going to step through this. And what we're going to do is we're going to change the timer for the read sensor timelet, and we're going to change that to be value of 2. And then we'll go through that, and then we will now also report back to IoT Hub, the device twin, that new value. In fact, if we hop across to Mustafa's machine, and if you share your machine now with the IoT Explorer there, and if you scroll up a bit and do a refresh and now scroll down, you'll see on Mustafa's machine that there is a reported section. In fact, just do a refresh on that again. And, oh, maybe it's because my application has broken. Hang on. That might have been my fault, Mustafa. Go and do a refresh again. And you'll see that the sample rate, the application has reported back the sample rate of 2 seconds. The reason that didn't appear back immediately is because my application was sitting on a breakpoint and actually not actually returning that data back to IoT Hub. Alrighty, so that was those were the demos. So I'll just go back to my machine again, and I'm just going to double check if there are any questions that have come through. The question was, does the question there was, does the connection have to be a fully qualified? Yes, it does. So the answer to that one is yes. The next question here, which is a good question as well, is can users utilize these devices with .NET, Java, or Python? Okay, that's another great question. The Azure Sphere is a C development, and it's C development only, so you need to understand that. And what I've done here with the Azure Sphere Learning Path is appreciating that not everybody is a C developer. So what I've done with a lot of those helper libraries is to make it much easier if you're a Python developer or a Java or a .NET developer. There are some much higher level functions that you can go and use to make this really easy to go and build to. So great question there. So that's a situation with that. So it is C development at the moment. Alrighty, and I should also point out that the reality is that these are constrained devices. So these have limited memory on them, so limited RAM. So they're not really the types of devices you would run a high-level framework like Java or .NET, where you had managed memory and threads and things like that, managed threads. It's not that type of environment. This is a constrained environment. This is the world of microcontrollers. Okay, so just as a quick set of knowledge checks, excuse me. So first bit of knowledge check, and you'll see this in the learning module. In the Azure Sphere ecosystem, which component is missing from the following list? And you remember I mentioned the Azure Sphere SDK that you needed for Windows and for Linux. You need to set up and claim the device into a tenant, and you obviously need the Azure Sphere operating system. And someone's still hacking on the that website, which is absolutely fine. And which one's missing? And I'm going to go through this reasonably quickly in the interest of time. The thing that's missing is you need to set up the Azure Sphere security service. In fact, that's part of the deal. When you define and configure a device, you need that as well. And it's the thing, as I mentioned before, it's responsible for monitoring the health, the security health of that device, renewing certificates and things like that. So Mustafa, do you want to talk about this question?
Yes, sure then. So the second question is, your organization created an Azure Sphere tenant and then claims each of its devices into that tenant. What function does this accomplish? So the options are, so that you can manage those devices remotely and securely. The tenant allows devices to communicate better with other tenants. Your organization can name individual devices. I'll give you a moment to think about it. All right. So the answer is the option is A. So that you can manage those devices remotely and securely. And that is why what this function accomplishes.
Cool. Thank you, Mustafa. And the final question you'll see there, if the Azure Sphere service, security service were missing, what function could you not perform? And the answer is you would not be able to get the latest security updates from Azure Sphere. The reality is that you won't be missing the security service. It just comes an intrinsic part of it, the Azure Sphere kind of ecosystem, the device. And it's there, as I mentioned before, just to manage the health of the device for you. Okay, so in summary, if you hope you got an idea of building applications with Azure Sphere. If you're working on IoT solutions, please make sure that security is part of your IoT story. You do not want to be in the situation where you're building out IoT devices, either in your university courses or maybe you're building out something which is going to go to production. You do not want to be in a situation where you're having to record devices because you cannot update them remotely or things like that. So security absolutely needs to be fundamentally part of the security story. Security is difficult. Azure Sphere makes security much simpler because it's baked into the platform. You just need to think about your application, and you then need to go and basically define what resources your application can access. Super important part of Azure Sphere. So Azure Sphere is there about delivering on those 7 properties for highly secure devices. And the other important thing about it is security is a journey. And I'm sure we all appreciate that. We know that attacks happen on our computers, be it Windows, Mac, or Linux, and you know that there's ongoing patching and maintenance of our computer system. The same is true for IoT devices, be it the operating system or being it your applications. Now, one of the other things I like to talk about Azure Sphere is Azure Sphere will also help protect against bugs that you might introduce into your applications. You might accidentally try and access a resource which is not available. Azure Sphere really kind of touches, make sure that you can only access those resources. Yeah, cool. Okay, so as I mentioned before at the start of this, this session here is in support of the learning module that you'll find up on MS Learn, Microsoft Learn. So developing secure IoT solutions with Azure Sphere and IoT Hub. So do check that out. You need to make sure you've got an Azure Sphere device. If you don't have a device, then at least read through that, the hands-on labs, because you'll get a really great sense of what you can go and build, the types of applications that you can go and build. And then kind of really more importantly, to keep in mind that there are some follow-on sessions. So we've already had a session yesterday on the 12th, which was a DevOps on IoT Edge session. We've just had my session today. We've got another session coming up on October the 19th. This is Pacific Daylight Time, which is cognitive services with Azure IoT Edge. Super interesting session where you can look and learn about really kind of amazing things that you can do around AI and running those solutions on the IoT Edge. And I'll be back again the day after, which we'll be looking at not too dissimilar session of this one, but the focus is going to be more on IoT Central. And IoT Central makes it much easier to go and build kind of the back end part of a solution. So we're going to talk about some of that. So really, do keep those questions coming on Twitter on #LearnTV. We will keep an eye on those on questions. Do follow me on @dglover. And I would really like to thank Mustafa. So Mustafa, you might just want to say some words departing, and you might just want to mention your hashtag again as well.
Yes, so thank you for attending the session. It was really nice explaining everyone about Azure IoT Hub. And you can follow me on at I am Mustu and ask me any questions that you like. You can also find me on LinkedIn as Mustafa Saifi. And thank you for attending the session and have a nice day.
Hey, and thank you. And thank you very much, Mustafa, as well. As we started at the beginning, Mustafa is a student, and he's been going over a lot of learning curve on this as well. So really appreciate you taking out the time, because I think it's probably close to 1:30 or 2:30 AM in India at the moment. So I appreciate you staying up late to do this session. And thank you very much, everybody, for joining us on the web today. Hope you learned plenty. As I said, we will keep an eye on that hashtag on Twitter. So #LearnTV. And thank you very much for taking the time, and stay safe.